If your organization is like most, you're using open source software to create the next big advancements for your products and services. But open source software comes with risks. It's often the target of cyber attacks that can compromise your organization's data security. What's more, the burden of liability for security breaches is shifting to software publishers and manufacturers, leading to penalties and reputational damage. Every open source software package has dependencies that are difficult to track. One vulnerability in a single version can negatively affect your entire software supply chain. Anaconda provides trusted packages for your Python and R developers, as well as the security controls and IT governance capabilities you need to protect your organization and your data. Anaconda provides what no other platform can. We build our packages from source. They are tamper-free and privately hosted, so you can manage and distribute access to trusted packages for your Python and R developers, and secure your software supply chain from the start. In this video, we'll demonstrate how IT administrators can use Anaconda in the cloud and on-premise to shift from reactive to proactive in securing the open source supply chain. Let's start with Anaconda for the cloud. We'll begin with channels. Channels connect you to thousands of the most popular data science and machine learning packages available today. Business tier customers can manage package distribution across their organization by using custom channels. You can also create external channels that point to third-party repositories, such as Conda Forge. Using channels, you can give your users access only to the approved software packages they need. Policy filters add another layer of protection before coding begins by allowing you to remove unsafe and unwanted packages from your channels. Here, you can exclude access to risky packages. Let's say you want to filter packages by excluding packages with associated CVE scores greater than 7. Once applied, the filter will update channel contents automatically. Only approved packages will show up when users search a channel. Clicking a specific file within a package provides signature verification as well as metadata. Signature verification enables you to trust in the packages in your supply chain. You can view an SBOM, which is a detailed breakdown of all packages and libraries used in projects. Common vulnerabilities and exposures, also known as CVEs, are weaknesses in software that can be exploited to access sensitive information, such as credit card numbers or social security numbers. Unlike proprietary scanning solutions, Anaconda uses a rigorous process for curating CVEs, starting with the U.S. National Institute of Standards and Technology's National Vulnerability Database. Our Python and R experts assess affected packages and mitigate the vulnerabilities. Anaconda's business tier gives you access to CVEs. You can see the number of CVEs for a channel and drill down into vulnerabilities by package and version. To pull packages from your organization's virtual channels, first you must configure your Conda RC file to tell Conda where your channel is located. Copy a channel path, which you'll need when updating your Conda RC file. Open your terminal and run the Conda configuration command. This will show you your current configuration in Conda, which will check the specified channel for packages. If you want to restrict where you pull packages from, update your Conda RC file to only include that channel in the channels list. Your Conda RC file might look something like this. You can add the default channels to your Conda RC file's channels list at any time by running the Conda configuration command. For one of your users, accessing a package is as simple as selecting a channel and searching for a package within that channel. If a user attempts to access a package that is blocked due to a policy, they'll get an error message. Now let's take a look at security with Anaconda on-premises. Anaconda supports any deployment on-prem, including air-gapped and bare metal infrastructures. Anaconda on-prem uses mirroring to create a local repository copy, so your users can access approved packages from a centralized on-premise or cloud location. You'll create a mirror using the form. The source can be from Anaconda, but it doesn't have to be. With Anaconda on-prem, mirroring takes the place of the policy filters we covered in Anaconda for the cloud. Adding filters to your mirrors ensures that everyone on your team is not only using the same packages, but also the same version of those packages for the same operating system architecture. You can also filter by license and Common Vulnerability and Exposure (CVE) score to ensure that you are meeting your organization's software security requirements. Filters can also be applied to channels and in both standard and air-gapped environments. When a user needs a package, they can run conda install from the command line interface and download packages from Anaconda's server, the secure central repository which houses trusted packages. When you search for and select a package, you'll be able to see details, including versions, CVEs, and signature status. Clicking a specific file within a package provides further metadata, including signature verification, which allows you to verify packages are tamper-free and sourced from Anaconda's secure build process. Authorization tokens can be created by users and administrators to provide fine-grained access control to channels when using the API or command line interface. These tokens can be used in place of username-based authentication, particularly for third-party applications or automation tools. You can view an SBOM, or detailed breakdown of all packages and libraries used in projects. A passive software bill of materials mirror will automatically be created for you on your first login. You can view the status of the mirror's progress from the All Mirrors view. Here you can view or download the software bill of materials. You can also view CVEs that are associated with channels and packages, and see how many files are affected by each CVE. It's easy for a user to download packages from the repositories you've mirrored into your organization's channels. On a package details page, click on a file name to download the file. They can use familiar conda commands to install packages from repositories you've mirrored into your server's channels. Conda won't just download the packages, it will also include all of the dependencies needed to solve their environments. No matter how you deploy Anaconda, our enterprise support team is here to assist you. We understand the complexities of security in data science and machine learning, and our Python and R experts are dedicated to helping you navigate through any concerns or challenges you may encounter along the way. Get started today. Schedule a consultation with one of Anaconda's enterprise security experts.